A very good evening to all of you. Welcome you guys. Welcome you all. How you are doing, everybody? Very good evening to all of you. How you are doing, everybody? कैसे हो सभी लोग? I think we are live. Yeah. First of all, do comment करके बोलिए. Now is our audio videos clear to everybody? Do comment करके बोलिए. Audio videos clear to everybody? Right. चलो आज का सेशन हम शुरू करेगा. Yeah, सबसे पहले great news to all the aspirants of GATE and ESC for 2027 and 2028 के लिए. So there is a chance to get 90% of scholarship आपको मिलने का chances है अभी. So there is a chance to get 90% of scholarship and don't miss these opportunities. So don't miss this opportunity. The exam which will be on here 19th April and 11 a.m. and the other session is at 5 p.m. 2 sessions according to your time convenience you can able to plan it. Right, so we starting a new batches. We are starting. You can have a look at, and so here the new batches you can have a look at now here. So analog electronics is starting. You can have a look at from 10th April onwards. नया बैच शुरू होने वाला. You can have a look at now. Here this is the rank improvement batch. Signals is starting here. And these are the Unacademy 2026 rankers from Unacademy. You can have a look at. so क्या हुआ पीयूष? so जैसा गेट वैसा HPCL भी होगा क्या? So yeah, पता नहीं क्या होने वाला. Hope it won't happen. And Unacademy Una, the AI tool. So with this, there are 3 modes of operations are there. That is voice mode and quiz mode and smart summaries. You can directly talk to this Una. So according to a time, according to a requirement, you can able to ask the queries. And test series is live. We do offer the 2 subscription and plus subscription. The other one is Iconic का. प्लस में क्या चीज मिलेगा? टॉप एडुकेटर्स क्लासेस मिलेगा, लाइव डाउट सॉल्विंग, एवेल्युएटेड मेंस टेस्ट सीरीज, स्ट्रक्चर्ड कोर्सेस, पीडीएफ, लाइव टेस्ट एंड क्विजेस, अनलिमिटेड एक्सेस. आइकॉनिक में और क्या मिलेगा? Starters kit. So this is like what we can say, like a diary, pen. So this like that we can water bottle like that it is available. So this starters kit, if you want, get you that one. You can able to get that one from the Unacademy stores. Offline store you will get, nearby store you can able to access it. Right? Yeah, chale. So let's solve one by one problems. So a certain network consists of 2 ideal sources. No. Okay. A certain network consists of 2 ideal sources and a large number of ideal resistors. The power consumed in one resistor is 4 watts when either of the 2 sources is active, and 4 watts when other source is replaced by short circuit. Now the power consumed by the same resistor when both are acting simultaneously. So the power consumed during the first source, that is P1, So that is P1 given as how much? 4 volts when one source is active, and the P2 given as what tell me now here 4 watts when the second source is active. When both are active simultaneously, the power which will be given as what tell me, that is square root of P1 plus or minus square root of P2. Why this plus or minus will come? So it may be the current may be aiding, may be opposing. So इसलिए so we have to consider both. We need to consider it. So you can tell me now here the total P which will come to be a what tell me now square root of 4 plus or minus square root of 4 ka whole square. So this is which is equal to what tell me now here 2 plus or minus 2 whole square. अगर एक बार प्लस ले लिया तो here will come it as a so 2 4th square na 4th square will come दोबारा so 0. So that means how much will come here 16 watts and the other one is 0 watts. So option A. Next. A particular resistor R dissipates a power of 4 watts when V is active alone. When V is active alone, the resistor R dissipates a power of 9. When I is active alone, the power absorbed by R when both sources are active. Yes, same concept. Yes, so what is the net power we can say now here? So square root of P1 plus or minus square root of P2 ka whole square. So that is what should be the net power now here? That is root 4 plus or minus yes root 9. So how much will come here? So it will come to be a 2 plus or minus 3 whole square ना. अगर पॉजिटिव ले लिया तो 2 स्क्वायर 25 आएगा and negative ले लिया तो so what will come here? So it will come 1. So this is 25 watts and the other one is 1 watt. So option A and D दोनों सही ना? Why 5 या? Option B क्यों या? Amir 5 square. Right. Now try this one. When Vs is equal to 120 volts, it is found that I1 is equal to 3 amps, V2 equal to 50, and power delivered to R3 is given 20. And if the Vs is equal to 105, then the new values they are asking. So we can find now here. Initially Vs source voltage 120, thereafter source voltage change it to 105, isn't it? So we can find the K value. K is nothing but what tell me now here new by old. K is what tell me now new by old value now. So we'll come to the new value is 105. Old value is how much now here 120. So how much will come K value? Tell me now here. That is 5 2s 1s, 5 2s and 4. Again, so 3 7s, 3 8. So this is the ratio which is 7 by 8. That means excitation is multiplied by some constant K. The response is also multiplied by the same constant, isn't it? So you tell me now here, initial value of current. Initial value of current, as we know, according to the homogeneity property, if the excitation is multiplied by K, response is also multiplied the same constant. So we can say this as I1 dash, new value, which is equal to K into I1. Na? So that is given as K value, how much now here? That is 7 by 8 into I1, which is equal to how much now? New value, old value 3. So how much this current, you see this thing here, this is 21/8. Next, and V2 dash, which is equal to what terminal? K into V2. So here K value, that is 7/8 into V2 value, how much now? 50. So it will come to be a, so this is 35 now by 8. Next, that is power. What are the power, you tell me now here? So it is a voltage and currents are multiplied by K, whereas power is multiplied by what, tell me now here? K square. Power equal to product of voltage into current. K into a K square will come. So this is P3, we can say. K value how much now here? 7/8 whole square. P3 value how much now? This power is 60. So how much this value will come? कौन सा ऑप्शन चेक करके बोलिए, क्या आएगा वैल्यूज? How much? Yes, कैलकुलेट करना पड़ेगा. So first one 21. सी किया ना आप लोग? सही किया ना? 21/8. So this was 2.625. Okay. Option C. Next. The linear network contains only resistors if IS1 is 8, IS2 12, Vx is found to be a 80. If IS1 is -8, IS2 is 4, Vx is 0. Then they are asking to find the Vx value when IS1, IS2 equal to 20. Yeah, you tell me now here. As we know, the response in any element which will be given us, what we can say here, we can say K into, we can express a linear combination of individual responses. K into, we can call this as IS1, K2 into IS2, right? Vx value, how much now we are found to be 80. They given this, when the first condition given this thing, now we can put this condition. So over the condition what they given, you can see it now. And they given, what they given now here, when IS1 which is equal to 8, next IS2 which is given as a 12, they given the Vx value given as 80. This is the first condition. And second condition is, what tell me now here, IS1 equal to -8 and IS2 given as a 4, and they given the Vx value given as how much now? 0. Now we'll substitute the two condition in the above equations. So tell me now which will come to be 80 equal to what, tell me now here, 8 into K1 plus 12 into K2. Next, which is equal to 0 equal to what, tell me now here, -8 into K1 plus 4 into K2. By adding this, if I add this thing, so this K1 term will get cancelled, right? So will come to be how much now here? This is 80, which is equal to 16 K2. So how much this value of K2 will come here? That is 5. Now what are the K1 value? So this is 8K1, which is equal to 20. So K1 value, how much now here? 20 by 8. 4 2s 4 5. So which will come to be a 5 by 2. Now we got the finally, so we can put this Vx K1 K2 values. K1 value, how much now here? 5 by 2 into, that is IS1 plus 5 into IS2. So now finally given IS1, IS2 given as a 20. So we can put the values now here. So we'll get the Vx value as what you can see now here, 5 by 2 into IS1, which is equal to 20 plus 5 into IS2 also 20 only. So this 2 tens now here. So will come the Vx value as what? Tell me now. This is 50 plus, so this is 100. So how much will come? This is 150. Right. Next. Superposition theorem is not applicable in the network when it is. It contains non-linear case. SPT, superposition theorem, is not applicable. SPT is applicable only in case of a linear networks only. Next. Superposition theorem is valid for what? Tell me now here. Yes, all linear networks is valid. Linear and symmetrical networks, only linear networks having no dependent sources, linear as well as non-linear. So here, only linear networks having no dependent sources. Linear networks having no dependent sources, this can be valid. Okay, not only symmetrical, asymmetrical also valid. Okay, option B may not be B. So not only symmetrical, asymmetrical also valid, but only thing is the network must be linear networks. Next. In a linear circuit, the superposition principle can be applied to calculate. For which case we can apply here? Tell me now. Voltage is a linear, power is a non-linear. So power calculation we cannot use the SPT. K square will come now. That's why. So for what case we can use now? For voltage and current we can apply the power. Why? Because power is a non-linear parameter. Next. Yeah, you can see now here. In the circuit shown, the power consumed in the resistance R is given as like this. 3 sources are given. So when all sources are acting simultaneously, the possible maximum minimum values of the powers is maximum minimum values. Good problem. So P1, P2, P3, they given are 3 powers are given. So what is the power possibilities now here? It should be given as, we can take it as a plus or minus P1 plus or minus P2 and plus or minus P3. Sorry. So root of P1 plus or minus root P2 plus or minus root P3 ka whole square. So this P, which is equal to what? Tell me now here. That is plus or minus root of P1. How much is P1? You can see now this is root 18 plus or minus root of 50 plus or minus root of 98. या कैलकुलेट करके बोलिए ना क्या आएगा. Agar if I want this maximum case, all must be a positive first thing. Okay. All must be negative we should consider. So positive we have taken maximum ke liye. So we have taken all are positive. So how much this value will come? And minimum के लिए tell me now here. Minimum के लिए what about the minimum के लिए? So here the small twos are one side and the big one is other side. So if you have taken, so this is positive we have taken, and 50 also positive, and this 98 we have taken as negative. In this case the minimum possible. Check करके बोलिए. Now simplify करके tell me the what will come here. So root 18 plus root 50 plus root 98 का whole square. So this maximum which we got it as a 450. Okay, minimum के लिए. So here minus if I place, that will be come to be a 2. Check करके बोलिए. The other combination may not be minimum. So the option C. Next, the power dissipated in the 1 ohm resistor is 1 watt due to 5 volt source, and 576 due to 30 ampere current source. The total power absorbed in the same resistor due to both the sources. Yeah, tell me now this power, total power. Yes, so that is given as square root of P1 plus or minus square root of P2 whole square. So simplify it now. That is square root of P1 which is 1 plus or minus square root of 576. So that will come to be a what, tell me now here. 1 plus or minus, this is 24 now. 24 whole square, right? So that means we can say the minimum power के लिए minus we have taken, that is 23 square, and maximum power which will be equal to 25 square. So this 23 which is a 529, 25 which is 625 watts. So in this case both option has to be considered now. Here they didn't mention whether we should be taken minimum or maximum. Okay, both can be the possibilities. Yeah, next one. Yes, in the given circuit, superposition is applied. When V2 is set to 0, the current is minus 6. When V1 is set to 0, the current I1 is plus 6. The current when both the sources are present. Okay. So when V2 0, the current I2 value given as minus 6. When V1 is 0, I1 is plus 6. When V2 is set to 0, so they given this current. So this is the current because of the first element, we can say. I1 if I call, how much is I1 value? Which is given as 6 amperes. Next. When V2 set to 0, that is minus 6. Na? Minus 6. Okay. When V1 is set to 0, I1 value plus 6, they ask him to find this current we need now here, basically. Okay. So this I1, this current is minus 6 means when this V2 value 0, so we have this current. So that means this current, which is equal to 6 amperes. That means this current is 6 amperes. When this is set to 0, the current will divide now here between. Now, if I call this current through this one, if I call this current, this is now here IA if I call when V1 is active. V1, no, V2 is shorted. When V2 is 0, so what is this IA value? Tell me now here. Current will divide between these two, right? So will come to be here. This is 4 by 10 into 6, which will come to be a what? Tell me now here, 2.4 amps. Next, they given when V1 is 0, when V1 is 0 volts, now what should be condition now here in this case? Yes, now V1 is 0. This is shorted when V1 is 0, and they given what they given now here I1. So this current is given as 6 is given. This current is 6, but we need this current we need now. This current we need. So this current is 6 means, so this voltage which is equal to 18 volts. That means same voltage here also. This is 18 volts. That means this current is 3 ampere. So that means if I call this is IB, how much is IB value? 3 amperes. Okay. Now when both are active, so you can see now both the currents are downward direction only. So this I3 is given as, that is IA plus IB. IA plus IB. So this IA plus IB together will come to be a 5.4 amperes. Okay. Good problem, isn't it? बढ़िया प्रॉब्लम ना ये आपको लग रहा कि नहीं? आपको बोलिए. Okay, fine. Yeah, that's it for today's session. So here we'll meet in the next session. Okay then, see you. Bye bye.